Hello, this is Randy. Let's say that you are a computer programmer and you need to label some larger piece of code as a specific variable. What we're doing today actually helps prepare us to draw those connections between the larger concepts and the more simply stated variables. Let's go. So here we need to decide which of these patterns we can use to factor this expression. And one of these three patterns will not necessarily be the answer because it's possible that none of these patterns will directly correspond to this expression, in which case the answer could be none of these answers. So let's figure out, first of all, what would be a candidate answer for this expression. Well, looks like we have three terms, 1, 2, 3, and we have plus and plus. So which of the answers has three terms and plus and plus? So it looks like A could be the answer, but we're not sure yet because we need to make sure that we are able to identify a U and a V, and we need to make sure that the middle term is 2 times that U times that V, okay? Now, we can see right here that U squared is the first term, so U would be the square root of that first term. Can we get a square root that has a whole number as the coefficient, the first part, and a variable with an exponent that is a whole number? And in this case we can. If we take 4x squared and we do this, the principal square root, we're going to get 2x, because 2x times 2x is 4x squared. So 4x squared could be rewritten as 2x all in parentheses to the power of 2. Okay, so we just identified U. 2x is U. Now we're going to skip this middle part for now. We're just going to put plus, and then we'll come back to that at the end. Now here we have 25, which corresponds to v squared. So if v squared is 25, what is v? Well, it would be the principal square root of 25, which is 5. So right here we're going to put plus 5. So far things are looking good because we have now identified 5 squared, just like that. We have now identified U, which is 2x, and V, we'll write V over here, which is 5. Now, the next question is, if we do 2 times U times V, are we going to get 20x? If we get 20x after we do 2 times U times V, then we know that A will be the answer. So let's do that here. So we already know what is U and V, so we're going to say 2 times U is 2x. So 2 times 2x times V is 5. So 2 times 2 is 4, times 5 is 20. So we have 20x. So there it is, 2uv is 20x, which is exactly what we had in the original expression. So to summarize, we have now identified both U and V, and both of those are whole numbers with a variable that has an exponent that is a whole number, because notice that 5 is the same as saying 5 times x to the 0, and 0 is a whole number. And lastly, when we do 2 times U times V, we get exactly what we had as that middle term. So in this case, the answer is in fact A. Now this next example is very similar. So this one is 4x squared plus 20x plus 25. And this next one is 4x squared plus 20x plus 36. So we already know that we have two pluses, so the candidate answer is A. Now we want to make sure that A is the answer because we don't know yet, because this expression is a little bit different. So we're going to write over here, we already know that U is 2x, and V is going to be the square root of this part of the expression. So the principal square root of 36 is 6. So V is going to be 6. And here's our candidate answer. Now let's write over here 2x squared. So there's U squared, just like we have U squared right here. And then plus something. We don't know yet. And then we're hoping it's 20x, but we don't know. And then plus V squared is 6 squared. Now we need to find out what is the value of 2 times u times v, just like we have right here. If our simplified expression of 2uv is 20x, then once again we know the answer is A. So we already know u and v, so 2 times u, but we already know that u is 2x, so 2 times 2x times 6 will give us what? 2 times 2 is 4, times 6 is 24, that will give us 24x. Okay, now 2uv we just decided is 24x. Is that the same as the middle term in the original expression? It is not. It is not, which means that A is not the answer, and we already know that B and C are not the answer because B has a minus right here, and C only has 2 terms. So the answer in this case is actually D, none of these answers. So this third example uses that same logic, but it's a little bit more complex. So our candidate answer here is going to be B. You can see that that's the case because we have a minus, plus, and 3 terms. So let's identify what is U and what is V, and then we'll go from there. So as we examine this expression, we can see that 9a to the 6th is a perfect square, and 81a to the 4th is also a perfect square, because when we take the principal square root of each of those, we will get 3a to the 3rd as the principal square root of 9a to the 6th, and 9a squared as the principal square root of 81a to the 4th. So u, in this case, is 3a cubed, and v is 9a squared. Now the pattern that we're hoping is the answer involves this middle term right here, minus 2uv. So we're hoping that 2 times u times v will give us 54a to the 5th. If that's the case, then we know that B is the answer. So here we have 2 times u times v. And when we multiply these, let's see what we get. So 2 times 3 is 6, times 9 is 54. We have 54, and then a cubed times a squared will give us a to the 5th because we add the exponents, 54a to the 5th. And we can see that 2 times u times v is 54a to the 5th, which means that in this case, B is the answer. Now this example is the exact same as what we had in the last one, with the only exception of that exponent right there. Now we have a 6 instead of a 5. But notice that u and v will be the same because those come from this first term and this last term. Now we already also know that 2 times u times v is 54a to the 5th, as we discovered. So is 2uv, that is 54a to the 5th, the same as the middle term that we have in this example? No, it's not, because the exponent is different. This should be a 5, which means that none of these first 3 answers, none of these patterns will be it, because 2uv needs to be 54a to the 5th, which means that D is the correct answer. Now this type of example is even easier because we only have 2 terms. If we have 2 terms and we have a minus right here, we know that our candidate answer will be C. If this first term and this second term are both perfect squares, then we know that C will be the answer. And when we take the principal square root of this first term, we get 4k cubed. And when we take the principal square root of the second term, we get 9k to the 4th, which means that both of those 2 terms are perfect squares, and therefore C is the answer. Now this last example is the same as the previous one, with the exception of this exponent right here. We have a 9 instead of an 8. So can we take the square root of 81 and get a whole number? Yes, the square root of 81 is 9. But if we take the square root of k to the power of 9, we cannot get a variable that has a whole number as an exponent. So 81k to the 9th is not a perfect square, which means that D is the answer for this example. And with that, we are finished. See you next time.